All right, I'm doing a quick video covering some of the questions I've had on the homework for Chapter 11. All right, some of the questions have been dealing with those problems, asking you for the probability of getting a prime number out of a certain set of numbers or a composite number. So you need to understand, of course, the differences between those two things. So let me just put some examples of prime numbers. So a number like 2, 3, 5, or 7. Sometimes people think prime numbers are odd numbers together with 2, but that's not really the case. 9 is really composite, okay? Because the idea is that to be prime, the only factors of the number need to be 1 and itself. So that means the only whole numbers that go into it have to be either 1 or itself, okay? So there is only one even prime number, and that's 2. The rest of the prime numbers will be odd numbers, okay? But not all odd numbers will be prime. So don't forget numbers like 9 or 15. Those are actually composite, together with all the other even numbers would be composite. All right, so that should be enough to get you started, except for you also have to understand that 1, the number 1, is neither prime nor composite. So if they're asking you for the likelihood of getting a prime number and 1 is included in the set, don't count that as prime. Don't count it as composite either. All right, now the other questions have been dealing with the problems involving this chart. So I've copied the chart, you see it there, that shows the number of possible hands you could get when playing poker that would be of a certain type. So like there's 4 possible hands that would be a royal flush. There's 3,744 possible hands that would be a full house, and so on. So there's several questions you get on that. And of course, the questions you get might be slightly different than the ones I'm showing you here because it'll change that up. So these would be problems 13 through 15 on 11.1. And then there's also one in the 11.2 homework, question number 12. Okay, so let's go ahead and just let me go ahead and look at my, the ones I got when I opened up the homework, and then it'll generate different problems for you. Okay, mine wanted the probability of getting a royal flush. Okay, so that's all face cards of a particular suit. So it tells you that there are 4 possible royal flush hands you could get. And it also tells you the total. See down at the bottom, the 2,598,960. That's the total possible number of hands you could get. And remember, we got that by using combinations, by taking the 52 cards and choosing 5. Okay? And that gave us the number that you see there. Okay. All right. So they've already given you the chart, so you don't really have to go back to the combinations. You just need to take 4 and divide it by that 2,598,960. Now, I'm thinking that some of the issues might deal with rounding. So let's look at that. So when you do this, you get point with 5 zeros and then 1539. Most calculators go to that many decimal places. All right, now the problem says to round, let's see, to 8 decimal places. That means 8 places to the right of the decimal. So if you count over 8 places to the right of the decimal, that would get you to where you see the 3 right now, but there's a 9 following it. So don't forget to bump the 3 up to a 4, okay? Because you're saying that number is closer to 0.000000154 than it is to all those zeros, 153. You're telling which, that it's what it's closest to 8 decimal places, okay? So sometimes it's that little rounding piece that messes you up, but you have the general gist of how to set it up. All right, so, don't forget, you can do a similar problem and fix your issue with rounding. All right, so let's do that chart, use that chart, and let's do another one. So it's the same concept on a lot of these. Let me grab that chart and move it down here on this page. Okay. So my next problem was very similar, but it said, okay, find the probability of getting a 3 of a kind. So once you saw how to do the other one, you should know how to do this one. So give it a try, and then you can check your answer. So stop the video and try it, and then check if you're doing it right. Okay. So it's just like the other one. It tells you that there are 54,912 possible 3 of a kind hands, and you know the total number of possible hands. So you just divide those two, and then double check your rounding. Okay. And so when you round to the 8 decimal places, since the 9th spot was just a 1 and you're rounding to 8 places, that means you would just write it as 0.02112,845. And that would be your answer on that one. Okay, so that one was pretty straightforward. Now the one that's really tricky is the next one. So this was my question number 14. Previous one was my question 13. All right, and then on 15, it's a little bit, not a little bit, it's a lot harder. Okay, so let's look at 15. 15 says, what's the probability of being dealt 4 sixes? 4 sixes. And of course, that's not explicitly in the chart, so you have to think a little bit about this. Okay. So like if we just looked at the probability of getting a 4 of a kind, we have that information. We could do the 624 out of the total number of possible 5 card hands we could get. So that's the same as what we did before, but it didn't just say what's the probability of getting a 4 of a kind. It said 4 sixes. All right, so there's a couple ways to kind of reason through this. This is kind of like what we were talking about when we were actually working on section 11.2. So even though this is in your 11.1 homework, I think the concept kind of fits better with the 11.2 material, because it's like you're trying to get 2 events to happen. You want them to be a 4 of a kind, but then you want them to all be sixes. So one way to do it is to say, think about all the 4 of a kind hands you could have. They could be sixes or threes, or they could be jacks. So you've got all of those different numbers that could be that you could use to make your 4 of a kind. And if you think about it, aren't there 13 different cards? They could all be aces, or they could all be ones, or they could all be twos, and so on. So you've got those 13 possible cards, and any one of them could be the type of 4 of a kind you're looking for, and any one of those would have the same probability as getting 4 sixes. So one way to think about it is that to take that 1 out of 13 chance of getting it to be the sixes times the 624 out of the 2,598,000, all that big number. Okay. All right, so you can do that, and you can take that and multiply the 1 out of 13 times the 624 out of that large number we had, and that'll give it to you. And I kind of thought about it that way, but just a little differently. I just thought about the 624 number as being all the possible 4 of a kind hands. And then I thought, some of them would be 4 ones, some would be 4 kings. So, in effect, I just divided it by 13 to find out then, well, what would be the number of how many 4 of a kinds you would have of a particular type of card. So if you do that, that's the 48. So you'd have 48 4 of a kind hands that would be aces, 48 that would be ones, 48 that would be twos, and so on. So rather than thinking of it as 1 over 13 times the 624 over that big number, I just made my numerator 48 instead of 624. It's the same though, isn't it? Same idea, isn't it? Because isn't that what happens when you multiply by 1 over 13? See how the 13's in the denominator, 624 is in the numerator. So the 13 in effect gets divided into that 624. Okay, but there's a good reason why you struggled a little bit with that question. It actually belongs in the section 11.2 material, really, since you had that multiplication going on. It was really the and type of probability problem that we talked about later in section 11.2. Okay. All right, let me do one more. This one's not quite as bad as that one to understand. Let's look at the one from that was in the 11.2 section. This one asked for the probability of being dealt, and this is in the 11.2 homework, probability of being dealt. And on mine, it said a straight flush and then or, and a 3 of a kind was the other possibility. Now remember, when they make this chart, each hand is classified into one of these various areas. So there's really no overlap. Like, in other words, if you had 4 sixes, they don't count that in the 3 of a kind hand. That would go in the 4 of a kind hand. So these are all, there's no overlap. There's no hand that counts in more than one area on here. So that's kind of important when you think about how to work this. So if you just think about the straight flush possibilities, there's 36 of them. And then for the 3 of a kind was what mine asked about. There were 54,912. And if you can be straight flush or 3 of a kind, then think way back to our chapter 2, to our sets idea. If you're doing or, that means it can be one, the other, or both, right? So you would add those two together, okay? And there's no overlap, so you're not double counting possibilities. So just add those two together out of the total number of hands. All right, now when you do that and you do the math on that, you still have to watch for your rounding. So you'll get 0.021142,303 is what I get on mine. That's as far as mine will go. And then this one, the rounding, I don't know why they changed it, but on the previous problems in 11.1, it said 8 decimal places. Watch it. This one says 6. So when you count that, you look at 6 places, you look at the number after it, and since it's less than 5, that means you're going to drop those digits and just have 0.021142, and that's what you need to put in for your answer. All right, so try not to get frustrated. If the issue is rounding errors, then you just need to be a little more careful on that rounding part when you do a similar problem. All right, let me back it up to that one. I never gave you the answer on that. If you work out back on question number 15, that one, when you work it out, you wound up having a 9 in that 9th spot. So you had to bump that up. That 8th digit had to be bumped up to a 7. So your answer would have been what you see there, 0.0001847. Okay. All right. So I just wanted to do that real quick, see if that helps you get those homeworks completed. And you can also send me individual questions, and I'll help you individually.